delivery networks, and then more interesting topic, which is some of the work going on to actually interconnect content delivery networks. How many people know what content delivery networks are, or familiar at least with the term? Okay, good. So this presentation is going to start out talking about a little bit about content delivery networks, and then set the stage for talking about actually some of the ways that several people and companies have been talking about interconnecting content delivery networks, very much in the same way that ISPs are connected at the IP level. And then I'm going to sum up and talk a little bit about a test bed that's being rolled out to do this. So content delivery networks are solving poor and consistent site performance. So basically, distributed web hosting model. There's a lot of commercial CDNs. A lot of ISPs are building their own CDNs. And the business model is simple. The customer's content provider, very similar to web hosting, and the value is quality of service. CDNs are overlay networks built with specialized servers that look very much like web servers, with a couple exceptions. And then there's another component to a CDN, which is a DNS global load balancing component. The architectural components of the CDN are, first, there's a distribution system, which is a fancy name for all of the surrogates that are out there. These surrogates often communicate using a set of protocols for distribution and cache coherency and things like that. There's also another domain, which is what we call request routing, and this is what's put on top of DNS or with DNS to direct users to the closest piece of content in a distribution system. And there's also the accounting and billing stuff, but of course that's the boring part. A simple example of a CDN, and again I'm setting the stage for talking about interconnection of content delivery networks. In this picture we have a client here who is looking up a request that is a particular URL, for example, that could be distributed on a content delivery network. So the first thing is, of course, there's a request that goes to its local DNS server. CDNs will typically either embed their own DNS names into URLs, or they'll actually have a CNAME that references their DNS from a customer name. The first thing, of course, is the client will contact its local DNS server, which will go through a whole bunch of processes to eventually get down to to resolve the CDN name. So I've left out like the root server lookup and such. Eventually, it will go to a request router, which is owned by the CDN and is authoritative for the CDN. The special name that's doing the request routing. Of course, that will return the closest IP address to whatever you define as close. I mean, people use a variety of metrics and a variety of algorithms. The client, of course, will then contact the local surrogate in the CDN network that is the IP address that's returned from the request router. If the surrogate doesn't have the content, typically it's pulled on demand, though with streaming media, of course, push is also used as well. Request routing is probably the most interesting part of CDNs. It's the global load balancing piece, and knowing where content is as well as doing measurements to determine which surrogate is the best one to serve a given client. This is where the quote-unquote black art is in CDNs. It's also the piece that's interesting with respect to when I start talking about interconnection of CDNs, because the request routing system is really where the interconnection happens. So right now, simple. In terms of what the user sees a modified URL in a web page. Again, just walking through the distribution system again, it really is, in a CDN, the distribution system really is the overlay network, and the request router is the actual, the request router using DNS is really the quote-unquote routers of the CDN. One other interesting point that's come up with CDNs is because a CDN is serving lots of different customers, you actually have to use the host header to determine which URLs you're actually serving, because of course you could have overlapping easily have overlapping directory names within a URL space. So you use the host header, again, just like a standard virtual server on a web server, but you also have to have the idea of an origin server, which is where you actually retrieve the content if you don't have it. The other thing is because CDNs are operating on behalf of an origin server, which is what makes them different from web caches, is that you have to have a method so that the origin server or the user themselves can actually control the content in the network. So there's a set of signaling protocols that happen in a CDN as well. So now I'm going to talk about interconnection of these networks. I've drawn a very, very rough analogy here, and let me walk through these pieces. In a layer 3 network, of course, we all know routers route packets. In a CDN, we have DNS request routers that route DNS requests or user requests to a best surrogate. In layer 3, of course, the units of information that are being exchanged and being looked up are routes. In a CDN, you're really looking for is content, so you're really looking for URLs. Interconnecting a layer 3 networks basically means that you've agreed to carry traffic for another network. Interconnecting a CDN means that you've agreed to serve content on behalf of another CDN and ultimately on behalf of an origin server. And of course, right now we all know BGP used to interconnect layer 3 networks. There's some work being done on some protocols to interconnect CDNs. So what are the business and technical issues in terms of CDN interconnection? One of the primary business drivers and technical drivers in connecting CDNs is that ISPs want to deploy their own CDNs. And a lot of the current commercial CDNs have quote-unquote global footprint, meaning that they put their surrogates in all parts of the internet. So if you're an ISP and you're deploying your own CDN, how do you compete with somebody who has, basically surrogates in other people's networks? Because you probably don't want to own surrogates in other people's networks. So what you might want to do is you might want to actually create some kind of agreement with another provider to use some of its surrogates. The other reason is enterprise networks. Some enterprise networks are actually deploying their own CDNs, and as content providers want to move their content as far out, closer to the users as possible, they'd actually want to make use of the surrogates that are actually in enterprise networks. So there's a whole bunch of new business models here, and I think new ones will come up as time goes on. It's really hard to say where this is going to go on the business side. What we do know, there's several quote-unquote Tier 1 ISPs that have deployed their own CDNs and are currently looking for technology and partners to interconnect or to peer with. So one of the difficulties in interconnecting CDN networks is that the primary value proposition of a CDN is quality of service. So you're basically trying to get around the packet loss at network access points and at private peering points. So what we have to do is we have to make sure that once we interconnect CDNs that we actually don't destroy that. So it seems many people believe that what we need at the CDN interconnection is a much more intricate set of ways for expressing quality of service information. And one of the reasons why some people will disbelieve or not believe this is because of the difficulty in doing this. And I definitely acknowledge that this is a huge challenge. One of the other difficulties with actually having quality of service between providers is that when you introduce arbitrary topologies into the network, you end up with a hard problem of how to solve routing loops. In CDNs, it may be easier to solve this problem. There's many of us that believe it will be, because since CDNs are overlay networks, you really only have to have, in other words, there's no reason to have an arbitrary hierarchy of CDNs. You really can just directly connect because everybody is basically at the same level of the network since everyone's an overlay network. The other interesting thing that's slightly different with CDN interconnection is that you have to take into account paranoia about content assets. So there's the SLAs and the offline negotiation might be a little bit more complex because people are worried about who can distribute my content. Content providers probably wouldn't want arbitrary handoff of serving their content. So right now, a lot of this work that I'm going to be talking about now is basically a result of some work in the ITF. There's been 2 BOFs, and I'll talk about that in a little bit. But we've basically generally have a model that we're working with for working with some of these providers that are interested in peering. So the way this works is that each piece of content has an authoritative CDN. So this is the master CDN, or the CDN that has the relationship with the content provider. And it's pretty easily identified by the DNS name that points to the request router and the authoritative CDN. The authoritative CDN will then get the request from the clients, of course. So it can then decide whether it wants to serve the content or whether another network should serve the content. And right now, this is based on basically some arbitrary decisions that are decision-making process that is being incorporated into various products and proprietary implementations. Once the request is directed to another network, of course, then that network will serve the content. And there has to be some kind of offline SLA, just like in any kind of interconnection or peering, where you negotiate some kind of bandwidth. You can actually do negotiation of bandwidth for CDNs as well, because that's actually a way a lot of CDNs build their customers. But there's a couple things that have to be taken into account. Number one is you have to keep track of which networks are authorized to distribute which content, and you also probably want to make note of which networks actually have the content. So for pull-based distribution, this isn't so much an issue, but when you talk about push-based distribution for stream media, it's definitely important. The other thing that we're doing is we're taking what we call a black box approach. So we're abstracting a network very much in the way that BGP can aggregate a bunch of routes and abstract the internal topology away. We're doing the same thing for CDNs. So a couple other things that have to be configured with the CDN between CDNs when you want to interconnect them is you have to have some kind of way to determine what information or what content should be distributed between the networks, what content types are supported. So if I support real media serving and you support Windows media, then how do we resolve that, or do we not just distribute content between us? When is the content ready? So in a push-based distribution, once the content is pushed, you want to actually acknowledge that you actually have the information. Accounting information has to be propagated to the authoritative CDN so that it can either give logs to its customers or present a monitoring interface to its customers. It's also required for multi-tiered settlement, which there's been some commercial proposals for multi-tier settlement. Content Bridge, some of you might know, is a group of vendors and providers that are getting together to propose a multi-tier settlement model for CDN interconnection. So at the really high level, you have 2 CDNs, and what I have is, in this case, I have a CDN that has a quote-unquote global footprint, but then I have an ISP here that might have its own CDN, and let's say that ISP is a smaller regional ISP, that the CDN, the larger CDN, doesn't actually have surrogates in there. So that actually wants to have some kind of interconnection here. So the content provider still has a relationship with CDNA, and these CPGs, or content peering gateways as we call them, basically talk some kind of protocols to interconnect these two. So the way that we're initially going to be looking at doing request routing between CDNs is through the use of DNS CNAMEs. Again, another picture here with a client looking up a DNS name that is part of the authoritative CDN's namespace. And if that CDN decides to redirect the request in step 3, where the request routing component is actually making the decision, then it will return a CNAME which will point to CDN2. So you actually make use of CNAMEs to do handoff of the request. So it works pretty nicely, and it's what's being used in the test bed. So this is just walks through the more concrete example. So if provider A has a particular site, or its particular authoritative name is cdnblah.com, then A would be authoritative for that name, which could be A's DNS name could be blah.com, or blah.com could be a CNAME into A's authoritative request routing system. So if provider B wants to distribute the content or to interconnect, it must apply a CNAME for redirection of that site. And then, of course, there's a policy at provider A. And the interesting thing here is that it's very hierarchical. So the authoritative request routing system makes a decision and then hands off the request down. So this is another thing that's slightly different from IP routing, where you can kind of hot potato around to whoever you want. This is pretty strictly hierarchical. Right now, as I said, we were focusing on DNS for the first ways to actually interconnect content networks, but there's also another way, which is to actually use layer 7 switches. So layer 7 switches have typically been used at a web hosting center to distribute requests between web servers. But if you actually move those switches to the edge of the network, you can do fancy things where you actually intercept a request at the edge of the network and direct it to the nearest server and avoid the DNS lookup. So right now DNS is used because it's convenient, it works across the board, but you could actually deploy a layer 7 request routing system. So for short term, for the test bed and for some of the protocols that we're looking at, DNS with mesh connectivity, so no arbitrary topologies. And actually arbitrary topologies are probably get into a lot of performance problems too that you don't want. So what you probably do, I mean, the way this is going to work is the hierarchy will be 1 or possibly 2 levels deep, and that's all. So you don't get a tremendous delay with DNS request routing. And then later on we'll figure out how to integrate it in with the layer 7. As we move forward, we want to have some protocols to exchange dynamic information. Right now everything that we're doing is being statically configured, so if you, another analogy would be we're doing static routing right now. Right now in some of the architecture drafts, framework drafts, in the ITF, we have concept of a content peering gateway. This is basically a server that would interconnect the two CDNs and exchange information. So the information right now that we want to exchange, or we think is useful to exchange, is quote-unquote coverage areas. So what you do is you map your CDN into effectively what your layer 3 network coverage is. And the second piece of that is specific content-related information. What content do you have, and is it ready to be served? What content types do you support, et cetera, et cetera. Lots of information needs to be exchanged. In reality, what will probably happen is this information will probably be pretty aggregate, especially at the stuff that's related to content. So we'll probably operate at the higher first 2 levels of a URL, if you will. There's a whole bunch of interesting problems in CDN interconnection. One of the things I want to stress is that this is very bleeding edge stuff. There's a couple people that are putting together this test bed and people looking at these problems, but this is very bleeding edge. There's a lot of problems still left to solve, and just like I was involved in some of the early MBONE stuff, and I think I would compare what we're doing right now to some of the very, very early stuff in the MBONE, where we're trying to learn about this, learn how this would work, see if we can still provide quality of service with the CDN that's interconnected, et cetera, et cetera. So these are some of the challenging problems to solve. You know, how do you make a routing decision? What information has to be exchanged? How do you prevent information overload? How do you ensure loop freedom of the request? Aggregating information, signaling metadata updates like purges between the two CDNs. So again, this is all very bleeding edge. There's something called a Content Alliance, which again, some of you may not. There's these two organizations, Content Alliance and Content Bridge. But Content Alliance is an organization that is trying to get together CDNs to figure out some of these problems. So right now, there's a test bed started by some of the Content Alliance members, and I don't even think the test bed is really related to Content Alliance anymore. I think AT&T is coordinating it right now. So the website at the bottom, cditestbed.net, is there's not too much information on there right now, but AT&T is coordinating this test bed, and we have several vendors and service providers that are participating in this test bed. And we have networks that are peered right now through DNS request routing systems using CNAME handoff. So everyone makes their own decision about who they want to hand off to. We don't have to worry about routing loops because we only have one level of hierarchy and mesh-based peering. Everything is static routed with the CNAMEs, and you just put per domain CNAME mappings if you want, and that's up to each provider. We are distributing several test sites on this test bed, and I think we'll probably ramp up with some more as we move on. What's the state of this? Where's it going? There's been 2 IETF bots. The group is called Content Distribution Internetworking, or CDI, and there's a mailing list here. I have it up here, and the plan is it should be an official working group of the next IETF. It's hung up in the area directors right now, getting final approval, and the focus of the group is on solving some short-term interconnection problems. We're going to start small and grow. We're not going to attempt to solve every problem right from the get-go because we know that never works. And we're going to use the test bed to try to figure out how this stuff is going to work in the real world. Here's a list of the internet drafts so far that are part of the BOPs and will be part of the working group. A lot of kind of framework type stuff. We're putting together requirements. See some requirements documents up there for the interconnection of these systems. So when we go to actually do protocols, we have something to reference off of. And there's some people actually starting to do some protocol work. So, summary. There's still a lot of things to solve. This is a brand new area. I'd say it's of interest to a lot of people here because a lot of service providers are building their own CDNs. There's been a couple, and I'm not going to mention names, but there's been a couple of large service providers that have announced either that they are building or already have built their own CDN. We have this test bed up and running, and right now we're doing static routing, but we probably will be adding some dynamic information exchange. And your input is greatly appreciated, and if you're interested in looking at the test bed, I think there's an email address up there. If there isn't, come talk to me and I will get you in touch with the right people. And thank you very much, and we'll take some questions. Okay, thanks.